Welcome back, guys. If you missed my previous class under dimension, there are some questions that already treat under dimension. Kindly go back to my YouTube channel. I'm going to drop the link after this video. Watch the video. Now, the next type of dimension I'm going to be looking at is work. We all know that work is said to be done when a force is being applied on the body and the body moves towards that direction. Then we conclude that a work is done. That is, we have work to be force times distance. Now, we are going to be looking at dimension for work. We have work to be force, which is being applied on a body, multiplied by the distance, because when a force is being applied on a body, for work to be done, the distance needs to be covered. Now, let's look for, we know that the dimension of distance is just L, because distance is represented with L. Lest I forget, before we move on, for mass, the dimension, you represent it with N. For length, the dimension, you represent it with L. Y for time, the dimension, you represent it with T. Now, length is talking about distance. That's how far the interval between 2 points. That's distance. Now, if you are solving for what's it called, distance, we'll just represent it with L, which is length of a place. Now, let's move on. But force. When we say force, force is mass times acceleration. In my previous class, I've already explained how to get the derivation for acceleration. That's the dimension for acceleration. Now, we're going to have mass to be m multiplied by acceleration is lt raised to the power of minus 2. Altogether, we have mlt raised to the power of minus 2. That's the dimension for force. Now, we have to bring the dimension down to that one of force. Then we have our work to be force, which we have the dimension mlt raised to the power of minus 2 multiplied by distance. I told you we are talking about the interval between two places, so we represent it with L. So we have it to be L. Altogether, we have m L times L, which is L squared, then T raised to the power of minus 2. So we have the dimension of work to be ml squared T raised to the power of minus 2. The next one we are going to be checking is called pressure. And we know that pressure is force over area. That is the force which is being applied on a particular area. So we have it to be force over area. Now, we already have the dimension for force, which we just solved. So we have the dimension for force to be equal to ml T raised to the power of minus 2. Why that of area? Area is length times length. So it's talking about distance, length times length. Altogether, we are going to have length squared. That is why anytime you calculate for area, you always have it in meter square, centimeter square, millimeter square, meter square. So that's why we have L squared. So if you have to take this and put it into the formula, we have the pressure to be equal to force is mlt raised to the power of minus 2 over length square, which is for the area. We'll have it L squared. Now, this have to move to the top. So we have mlt raised to the power of minus 2. Sorry, this place won't do. Let's do it here. mlt raised to the power of minus 2. As this one is coming up, remember, if this is coming up, it's going to become L minus 2 because of this division that is here. Now, this positive is just like it having a power of 1, so it's going to cancel this negative. We have m L minus 1. This positive has cancelled one of these, so I have to bring the negative remaining one here. Then we have T raised to the power of minus 2. So the dimension of pressure is mlt raised to the power of minus 1, T raised to the power of minus 2. Please, if this is your first time of coming across my channel, kindly subscribe to my YouTube channel at J Maths and Science. Thank you.